Hey guys, today's video is about data type. How is a dataset structured? The answer is through object, sample, observation, data point, and record. All these terms represent the same thing. For instance, a person, an animal, a product, and order number can be viewed as an object. And how is an object described? It's through property, attribute, feature, and variable. Again, all these terms are the same. They can be hair color and height, which describe the characteristics of a person. They can also be price and date of purchase, which describes a product. We now look at real data to have a concrete idea about objects and properties. The rows are objects denoted by their IDs. The columns are properties, and they describe the objects. We will discuss the data type of an attribute, since each attribute describes a characteristic for all objects. In a formal way, tuples, which are also rows, are datasets that used to uniquely identify an object. However, the uniqueness is not strict in this case. Two different objects can have exactly same properties. For instance, two people can respond the exact same answers in a survey, but they are still two different objects. The attributes, which are also columns, are characteristics that define all values pertaining to a certain column. And that's why the discussion of data type is based on attributes. To be more specific, the middle column here is the data types in programming language, but we are going to discuss data types in statistics. First, why do we care about data type? Data mining algorithms uniquely interpret different data types to make the computation more accurate and efficient, which is exactly what we pursue in terms of computing. There are two main data types, discrete and continuous. Discrete data has a finite set of values and cannot be broken down into a smaller unit. For example, hair color and groups are discrete data. On the other hand, continuous data has an infinite set of values or real numbers and can be reduced to a finite level. For example, height and temperature are continuous data, so if a girl's height is 160 centimeters, you can always say that she is 160.0 centimeters, and you can keep playing with the decimal points and break the number down to a finite level. Further, there are more precise data types. Nominal, binary, and ordinal are discrete data. Numeric, interval, and ratio are continuous data. To begin with, nominal data can be divided into non-overlapping categories, and there is no meaningful order between them. The important thing here is that the groups don't overlap with one another, and the groups don't have ordering. For example, ice color are nominal data since the colors don't overlap, and none of the colors is superior. ID number and gender are also nominal data. In fact, we can have many groups such as ID number as long as the groups don't overlap and don't have ordering. Second, binary data is a special case of nominal data with only two states. We can even ask the question about are outcomes equally important, and we can divide binary data into symmetric and asymmetric. The example for symmetric binary data would be response to a yes and no question, and the medical test result is asymmetric since the positive outcome is generally more important. We typically convert the binary data to 0 and 1. And we use 1 to denote the important outcome in asymmetric binary data. Third, ordinal data is data with meaningful order. For example, size and survey questions have ordering. In fact, ordinal data can be derived from numeric data. If we have age data, we can divide our participants into two groups, children and adults. Next, numeric intervals are integer or real. measured on a scale of equal size units. By equal size units, we mean the distance between any 2 points is standardized and equal. Also, there is no true 0 point, so we cannot compute the ratio of values. For instance, the temperature in Celsius is numeric interval, since we cannot conclude that the 20 degrees Celsius is 2 times warmer than 10 degrees Celsius. Last, the numeric ratio is similar to numeric interval, but it allows reasoning over multiple of values. In other words, numeric ratio has absolute 0 point. However, 0 represents the absence of the variable, so the numeric ratio cannot have negative values. For instance, count and height are numeric ratios. Count might look like ID, that ID can also be 0, 1, 2, and so on. But the number of ID doesn't have meaning, while the counts have ordering. The larger value represents a higher count. Just a quick review, discrete and continuous are two main data types. Discrete data can be nominal, binary, and ordinal. Nominal is the most general case that only requires the groups to be non-overlapping and no ordering. Binary is a special case of nominal with only 2 states, 0 and 1. Ordinal is like nominal with ordering among groups. Continuous data can be numeric interval and ratio. Numeric interval is not popular, and numeric ratio has true 0 points and allows reasoning over multiples. So, that's the basic idea of data types. Thank you for watching my video and see you in next one.